Hello viewers, I'm Kausalya. Today we are going to solve problem 3 related with y parameters. Here the problem is find the y parameters for the RC network shown below. So here this is the given network which has two capacitors and two resistors and it is a two-port network. So now here I am going to directly use the nodal analysis for solving this problem. So as a first step we are drawing the modified circuit. So here the modified circuit is nothing but we are going to express this capacitor values in terms of S. So here it is 1 by 2S, 1 by 2S and these two resistors 1 and 1. So what is the basic equation? So here this is your basic equation, that is I1 is equal to y11 v1 plus y12 v2 and I2 is equal to y21 v1 plus y22 v2. So this is the modified circuit. So in this circuit the first step is we are going to fix the nodes. So here this is your node 1 and this is your node 2 and this is your node 3. So here in this case this node and this node, okay, that is these 2 points they held at the same potential. So either you can mark this as node 2 or this as node 2, both has the same meaning. So now by nodal analysis we are going to write the equations and let I1 is the current flowing through this port and I2 is the current flowing through this port. So first we are considering our node 1. So to this node 1 we have only one capacitor and this capacitor is connected between node 1 and node 3. So while writing equation, and I1 is the current that flow towards the node 1. Okay. So here, sorry, not towards, it flows in the node 1. So here I1 is given by V1 minus V3 divided by this 1 by 2S. Since we are considering node 1, here we have to write V1 first. So V1 minus V3 by 1 by 2S. Now we are going to consider our node 2. So when you look at node 2, you see how many elements are connected here. To this node 2, we have two elements which are connected and this 1 ohm is connected only to this node 2. So first we will write the expression for this. So here it is I2. So I2 is equal to, here it is V2, right? So V2 by 1. So this is what I had written. And the next is this capacitor is connected between node 2 and node 3. So here while writing expression, V2 minus V3 divided by 1 by 2S. Right. So again when you rearrange, so here V2 by 1 becomes V2 and this 1 by 2S when you move upwards it occupies the denominator part, it occupies the numerator part, it becomes 2S by 1. So V2 minus V3 into 2S by 1. So this is our node 2 equation. Now look at node 3. To this node 3, totally how many elements are connected? 1, 2 and 3. Totally 3 elements are connected. So while writing equation, and you see there is no particular current flow in this node. So here the current is 0. It is 0. And while writing equation, you see here V3 by 1 because this one is connected only to the node 3. So V3 by 1 plus when you consider equation here, while writing this you have to, when you consider this capacitor, you have to write equation as V3 minus V1 divided by 1 by 2S. And similarly V3 minus V2 divided by 1 by 2S. Right. So since we are considering node 3, V3 should be returned first in all the cases. Now again when you rearrange, when you move this 1 by 2S, it occupies the numerator part. So here it becomes 2S by 1 and here also it becomes 2S by 1. So now we are multiplying and rearranging. So when you multiply, 2S into V3 becomes 2S V3 and here 2S into minus V1 becomes minus 2S V1 and here 2S V3 minus 2S V2 is equal to 0. Now I am going to combine the V3 terms together. So when you rearrange, you see here V3 and here 2S V3 and again there is a 2S V3. So 2S V3 plus 2S V3 becomes 4S V3. Right, and here when you consider this V1 and V2 terms, minus 2S is common. So when you take minus 2S, the remaining terms are V1 plus V2 is equal to 0. So again Here in these two terms V3 is common. So here the terms becomes 1 plus 4s. So V3 is given by 2s into V1 plus V2 the whole divided by 1 plus 4s. So this is the equation for V3. So now we are going to substitute this V3 value in equation 1. So this is our equation 1. Right, so I1 is equal to V1 minus V3 by 1 by 2s. So when you move this, it becomes 2s into V1 minus V3. So what is the V3 value? This is your V3 value. So just we are substituting. So the next step is we are going to take LCM. So here it is 1 plus 4s and here it is simply 1. So we are multiplying by 1 plus 4s on both numerator and denominator. So here it becomes V1 into 1 plus 4s and this term as such divided by 1 plus 4s. Now I am taking this 1 plus 4s outside. So 2s divided by 1 plus 4s and here I am doing the simple multiplication. So V1 into 1 V1, V1 into 4s, 4s V1 and here minus 2s V1 and minus 2s V2. Now again we are going to simplify. So here you see, here it is 4s V1, it is plus 4s and here it is minus 2s. So 4s minus 2s becomes plus 2s V1 and here it is minus 2s V2. So again here when you take the V1 commonly outside, so the remaining terms are 1 plus 2s minus 2s V2. So this is your expression for I1. So now we are going to compare this equation with our standard one. So I am multiplying this common term inside the bracket. So here you see we are having this term and this term. So what is the basic equation? So I1 is given by y11 v1 plus y12 v2. So here we have v1. So what is y11? So y11 is nothing but this term 2s into 1 plus 2s divided by 1 plus 4s. This is y11. So again v2, here also v2. So coefficient of v2 is y12. So here coefficient of v2 is this entire term minus 4s square divided by 1 plus 4s. So we have calculated two parameters. Now we are going to find the remaining two parameters. So for that we are taking our second equation. So here I2 is equal to v2 plus v2 minus v3 into 2s. This is our equation number 2. Now again in this equation we are going to substitute the value of v3. So before that I am multiplying, right? v2 into 2s, v2 2s, here minus v3 into 2s. So here in these two terms v2 is common. So when you take v2 outside, the remaining terms are, here it becomes 1. So 1 plus 2s minus this 2s v3. Now I am going to substitute the value of v3 here. So this is your value v3. Right. So as a next step here, this 2s into 2s I am multiplying. So it becomes 4s square. As a next step, and the remaining terms they remain as such, we are going to take LCM. So once you take LCM, you see v2 into 1 plus 2s. This term gets multiplied with this 1 plus 4s and here this term remains as such. Now the next step is we are going to multiply these two terms. So once you multiply here, I believe you people know this multiplication, right? 1 multiplied by this 1 plus 2s is 1 plus 2s and this 4s is multiplied with this entire term. So 1 into 4s is 4s and 2s into 4s makes 8s square. And here again minus 4s square into v1 minus 4s square v2. And denominator term is 1 plus 4s. And here again we are simplifying. So once you simplify, 8s square plus 6s plus 1 and here these two terms remains here. Now again I am going to take this v2 term commonly outside because here there is v2 and here also there is a v2. So when you take v2 outside, here it is 8s square minus 4s square. So 8 minus 4 is 4s square and plus 6s plus 1 minus 4s square v1 divided by 1 plus 4s and this is your equation for I2. Now I am going to split and write. So here v2 4s square plus 6s plus 1 divided by 1 plus 4s and here minus 4s square v1 divided by 1 plus 4s. Now we are going to compare this equation with the standard equation And here you see what is the coefficient of V1. The coefficient of V1 is minus 4s square by 1 plus 4s. So that is your Y21. And what is the coefficient of V2? So this is the coefficient of V2. So here it is 4s square plus 6s plus 1 divided by 1 plus 4s. So here finally we have calculated all the 4 parameters by using nodal method. So that's all. If you have any doubt, let me know in the comment section. Thank you.